In this video, I'm going to review how to find the missing side of a right triangle using the Pythagorean theorem, or this relationship that's shown at the bottom of the screen. Let's take another look at that. A squared plus B squared equals C squared. Sometimes it's written the other way with C squared first, but that doesn't matter. It's the same relationship. And let's look at that relationship for this triangle that's shown. We have sides of 3 and 4 that are at a right angle to each other. We call those sides the legs. They're the shorter sides of the triangle. The longest side of the triangle we call C. It's called the hypotenuse, and it is opposite that right angle. So A and B, it's not important which ones we label those as. They're just the short sides, but it is important that we label C as the long side. So let's square 3. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. So A squared is 16. B squared is 9. And C squared is 25. So look at how that holds true for this triangle. 16 plus 9 is 25. So 25 equals 25. And that's true. So that's interesting, but it doesn't quite help us solve problems yet. Let's look at an instance where we can try to find this long side of this triangle using that relationship. So let me square these short sides again. 6 times 6 is 36. 8 times 8 is 64. So let me label this as A and this as B. Again, it doesn't matter. It's just kind of helpful to keep track of. So A squared is 64 plus B squared is 36. I strongly encourage you to try to follow along with your calculator here. You're going to get more out of it if you can do that. If you don't have your calculator, pause the video and go get it. Sorry, I didn't mean to erase that. So now let's add 64 and 36 to get 100. So 100 is equal to C squared. But we're not interested in what C squared is. We want to know what C is. We can find C by taking the square root of both sides. By taking the square root of C squared, we just get C. By taking the square root of 100, we get the number 10. That's the answer that we were looking for. This long side must have a length of 10. But we needed to take the square root of both sides to find that. Let's take a look at an example where we're trying to find one of the shorter sides or one of the legs. We could start out by squaring those other numbers because we know that we're going to have to do that. 9 squared, or 9 times 9, is 81. And 15 squared, you can do this in your calculator. 15 times 15, or 15 squared, is 225. So let's put that over here. B squared is 81. C squared is 225. And we want to know what A is. So we have to do a little bit of algebra here. Let's subtract 81 from both sides. This is kind of a two-step equation here. That's going to cancel this out. And it's going to leave us with A squared is equal to 225 minus 81, 144. Now, we don't want to know A squared. We want to know A. So we need to do that thing where we take the square root of both sides. A is equal to the square root of 144, which is 12. Our missing side had a length of 12. All right, let's keep going with a few more examples. So once you've done some of this, you start to realize that you need to take the square root at the end. So why not take a little bit of a shortcut and memorize this formula? When we're trying to find the long side, we are going to take the square root of the sum of the other two sides, of the sum of the square of the other two sides. So we are going to square 15, and we're going to square 20, and we're going to add those up and take the square root of it. For the short side, likewise, we could say that a is equal to the long side squared minus the short side that we know. So in this case, it's going to be 50 squared minus 40 squared. And we're going to take the square root of that. I want to show you how you can do that with the calculator. I'm going to call up my emulator here. Takes me a minute to get this going. So I want to look back at our problem, 15 and 20. So we hit second and the square root button. So we're getting the square root function going, and we're going to take 15 x squared button plus 20 x squared button. Now we have exactly what we need to produce to get this answer. We click the enter key, and there's our answer, 25. Let's look at that other problem quickly. Our long side was 50. Our short side was 40. We're going to square those and subtract it underneath the square root symbol. So clear that out. Second square root. This is the part that really will help if you follow along. 50 squared minus 40 x squared. We see that's exactly what we want on the screen. And we hit enter, and we get our answer of 30. All right. So let's continue. This also works with decimals. And once you practice some of this, it gets pretty repetitive, and you can get really good and quick at it. So in this first problem, we are looking for a long side. And our sides, our shorter sides, our legs are 3.2 and 5.6. Do this along with me. I'm going to go over to the calculator. I can just go right here, clear that out. Second square root button, 3.2 squared plus 5.6 x squared, enter. Now we get a decimal answer. That's okay. In these kind of problems, you are going to get decimals quite a bit. We might round that to 6.4. Okay, let's take a look at our other example here. We know that one short side, one leg is 12. Our hypotenuse is 18, and we're trying to find the other short side. So I want to use this formula. A is equal to c squared minus b squared. Let me grab the calculator again. Our numbers are 12 and 18. We're always going to square the hypotenuse first. In this case, clearing the screen, second x squared. We put in our hypotenuse first. That was 18, the longest side, x squared. We're going to subtract, this time, our shorter side, which was 12, x squared. Enter. Now, sometimes, I wanted to demonstrate this, you will get a funny answer. 6 times the square root of 5. Most of the time, you're not going to want that answer. And by clicking this toggle key right above the enter key, we can switch that over to a decimal, and we get 13.4. That would be our answer to this question, 13.4. All right, let's take a look at one more set of problems. This is kind of a classic word problem style that involves finding the missing side of a triangle. They will talk about a hike or some travel where we go in different directions. In this case, somebody hiked 3 miles west. Then they hiked 2 miles north. The question is, how far were they from where they started? Well, all they're talking about is this distance right here. By the shortest path, what is that distance, which is really how far they are from where they started. So this is no more than a triangle where one side is 2, another side is 3. So we are trying to find the long side here. So I think we want to use the formula C is equal to the square root of a squared plus b squared. So let's put this in your calculator exactly like this. Second, and then x squared button, square root of 2 squared plus 3 squared. And then hit the enter key, and you should get the answer 3.6. And when you look at this picture, it kind of makes sense that that would be about 3.5 miles, a little bit longer than the longest short side. Let's take a look at another kind of classic question. Clear that off of the screen. A ladder question. So we have a ladder leaning up against a building. We're told that the ladder is 14 feet long. We're told that the ladder is 8 feet, the base of the ladder is 8 feet from the house. How far up the side of the house does the ladder go? Well, this is just a triangle, and we're missing one of the short sides. So in this case, we would want to use that other formula. A is equal to c squared minus b squared. So let's plug those values in, and you can do this directly into the calculator. Second, square root button, 14 squared minus 8 squared. You only have 2 numbers to work with here. So you're either going to square them and add them, or square them and subtract them. So that's what we have. Hit enter on your calculator, and you should get about 11.5 feet. And that makes sense that this would be about 11.5 feet shorter than the length of the ladder, which we know to be the longest dimension in this triangle. So I know that that was a little bit long, but this is a pretty important topic, and there's a few different aspects to it. So I hope that was helpful, and good luck with your continued practice on this subject.